Just wanted to do one here like number 20. Number 20 is sneaky good, so that's why I wanted to go over it with you guys here. Number 20, so we're solving rational functions. Not solving, I shouldn't say that. We're graphing rational functions, and we're finding some key information. We're finding the x-intercepts, the y-intercept, as well as the vertical asymptote. Okay, so we're going to do that here. Obviously, for rational functions, we also need the horizontal and or oblique asymptote, and we're going to be doing that a little bit later. But this is just how to find the x-intercept, the y-intercept, as well as the vertical asymptotes. All right, so for number 20, it is r of x equals x over x to the fourth minus 1. Okay, so we'll start off with the x-intercepts, which again, you just need to solve the numerator, so x equals 0. That was pretty easy. Y-intercept, plug in 0 for x, which again, 0 up on top. Doesn't matter what the bottom is. It's going to be the y-intercept equals 0. Okay. And then we have the vertical asymptotes, which again are my domain restrictions, which is just the denominator. So x to the fourth minus 1 equals 0. So this is for my vertical asymptotes, which I'll just say VA or VA. All right, x to the fourth minus 1. So you might look at this and say, well, okay, add 1 over and do the fourth root. You could do it that way, but you'd be missing out on this. Watch this. So x to the fourth, perfect square, 1 to perfect square subtraction. I can actually use the difference of two squares here. So I can do x squared plus 1 and x squared minus 1 equals 0. Now here's why I'm doing it this way. Because, notice, if I try to solve the first parenthesis here, so x squared plus 1 equals 0, if I subtract 1 and then say x squared equals negative 1, hopefully you recognize I can't take the square root of a negative number. And so you'd say, oh, that's imaginary. Okay? So, we just have to be aware that the reason why I did the difference of squares at the beginning, even though it was the fourth root, remember any even exponent is a perfect square, or can be used in a perfect square format. Okay, so this is imaginary, meaning that's not where an asymptote actually would be. Okay, so here's where they will be. So x squared minus 1 equals 0. And then if I add 1, x squared equals 1, x equals plus or minus 1. Alright, so positive 1 and negative 1 are where I'm going to have my issues. Those are my real asymptotes, so I actually have two of them there. So this one was kind of tricky because x to the fourth minus 1, a lot of students don't recognize, oh, that is the difference of two squares. But then you could have solved it by adding 1 and then taking the fourth root and said, oh, well, it's just 1. But you would have missed out that there's actually only two real asymptotes because two of them are imaginary, and that means there aren't asymptotes at all. So, just wanted you guys to be aware of that. So that's how you do the x-intercept, the y-intercept, and the vertical asymptote for number 20.